In today's lesson, we are going to look at vectors, advanced level pure mathematics. The first thing we look at, tinotanga tatarisa a comparison between vectors and scalar quantities. So this is our first subtopic, vector versus scalar quantities. In doing this, we are going to define what a vector really is. Saka chatinoti a scalar, so this is a definition. We are defining what a scalar quantity is. Saka chatinoti a scalar quantity, this is a quantity with magnitude or size only, and Saka we can define it as a component with magnitude, but the more looser term yatogona kushandisa is size only, and we really have to highlight the term only. That is what a scalar quantity is. If we are to go to physics a little and give examples of scalar quantities, the example here would be speed is a scalar quantity. It only has size. We can talk about mass as a scalar quantity, and we have a lot of examples to draw from. Saka, another example would be covering a distance of 3 kilometers in an unspecified direction. Saka speed, mass, maybe we should add distance panapa, etc. Adding on to a scalar quantity, we now have what is referred to as a vector quantity. So what is a vector quantity? A vector quantity is now a component with both magnitude, which is size, remember, and direction. So what we add to a scalar quantity is the concept of direction. And if we are to give examples, following the examples we had given here, tikawedzera the component cannot the aspect of direction to speed, we come up with velocity. So velocity is the vector quantity when speed is the scalar quantity. Then when we have weight is going to be the vector quantity to mass being a scalar quantity. Then displacement is the vector component when we consider distance as the scalar component, etc. Saka changowedzerwa panapa is the direction. So if we have a quantity, a component with only size, magnitude, it's scalar. But when we now have a component with both magnitude and direction, it now becomes a vector quantity. After we have defined a vector, to consider also what a scalar quantity is, we are now going to look at the standard notation of vectors. The standard notation of vectors. So what is the standard notation of vectors? A vector quantity can be represented by a line segment with the direction specified. Saka, a vector quantity So most of what we are doing now, we are simply constructing what we learned in ordinary level when it came to vectors, then we want to build upon that. So a vector quantity can be represented by a line segment with the direction specified. So what do we mean kana tichiti it can be represented with a line segment? So this is segment with the direction specified. An example would be A, B. Then pana A, B, pana papamsoro, we put an arrow which is going to be specifying the direction. That is what we are referring to. Kureva kuti tinenge tina A, which is the origin. Then we have B, which is going to be the end. Then we specify the direction like that. That is what we have. But we are going to see with some books, some mathematical literature represent a vector. So a vector can be represented what can it be represented with? It can be represented by a single bold letter. I do not encourage this, especially kana imimi muchi nyorama vectors, but you are going to find mathematical literature using this nomenclature. So a vector can be represented by a single bold letter. And example here is we can have a vector A, a single bold letter. So maybe it's like this. Saka we have a line which also has an arrowhead irikutudza direction. Then the vector is represented by a single bold letter. I do not encourage this second form of representation. I would that you represent it using the first form, a line segment with specified direction. Okay, tichiri panapa, vectors can be represented horizontally. Vectors can be represented horizontally. And our example panapa is 2I plus 3J. So we are going to see kuti I, J, and also K, sometimes X, Y, and Z are going to be letters which are used in vector representation. But to represent our vectors horizontally, we can also represent them in column form. So they can be represented horizontally or in column vector form. And when we are representing them in column vector form, we are going to drop I and J. So as we progress in our learning, you are going to begin to learn patinenge ku differentiate between position and displacement vectors. So you are going to see the significance of losing those letters I and J. But kanata ku represent in column vector form, we are going to drop the letters. It's just going to be 2, 3. Shona. Saka panapa will be representing a vector in 2 dimensions. That is why we only have 2 components, 2 na 3, cannot 2I plus 3J. Okay. Now we can have vectors represented in 3 dimensions. Let us start off by specifying that vectors can be represented in 2 dimensions. And when they are represented in 2 dimensions, that's where we have this example. Let us use this 2I plus 3J or 2 to 3. And if I want to represent what is happening here, it's more like this. These are the 2 dimensions we are talking about. Then we have our vector representation. Of course, the vector is going to be represented by a straight line with specified direction. Saka kana chiti 2 dimensions, basically tiri kureva the xy plane. That is what we are referring to. We are going to elaborate this more as we progress. Now, adding upon this, vectors can also be represented in 3 dimensions. In 3D. Kana kuti 3 dimensions. Example, 3i, take 3i minus 4j plus 5k. This will be the horizontal form or the vector column form. And I'm going to only the numbers 3 minus 4, 5. And what we are referring to panapa kana chichi 3 dimensions, it's something like this. Saka this will be the space in which a vector is represented. Saka this is y, x, and this is z. Not 3 dimensions that negate chitaura nezvadzo. Saka these are the 2 dimensions and xy, and 3 dimensions it's x, y, and also z. The first thing we are expected to do and to know is how to express vectors in column form. So when you are given vectors, you should be able to express them in column form. That is the first exercise we are going to be doing. In our next lesson, tichatarisa position vectors and displacement vectors. Basically, we are going to look at the types of vectors. That is going to be the content of our next lesson. Now, if you have derived some benefit from this lesson and wish to join us in extra lessons, you can WhatsApp us on +263, which is simply the Zimbabwean code 7152133110. Take care.